Hello, good day everyone. We are now in topic 3.1 of our basic calculus subject, which talk about continuity at the point. The competencies. At the end of this session, you are expected to illustrate continuity of a function at a point and determine whether a function is continuous at a point or not. As we have learned in our discussion of limits in topic 1.2, there are functions whose limits are not equal to the function value at x equals c, meaning the limit of f of x as x approaches c is not equal to f of c. That means the limit of f of x as x approaches c is not necessarily the same as f of c. What does continuity at a point, limits and continuity at a point? What does continuity at a point mean? Intuitively, this means that in drawing the graph of a function, the point in question will be traversed. We start by graphically illustrating what it means to be continuity at a point. So, sa imong paminaw, unsa man jud ang continuity? Okay, let us first consider the first example. So this graph is an illustration of f of x equals 3x minus 1. Is the function continuous at x equals 1? So what are we going to do to check if this function is continuous at x equals 1 using the given graph? We are going to look at the graph from the left of the number x equals 1 going to the right. So atong i-drawing ang graph going to the right without lifting our pen. Then notice that kan sa left padong sa right, inig-agi nimo sa 1, way bukto inig-drawing nimo sa imong pen. So since wa may bukto, that means the function is continuous at x equals 1. No? So parihara po nas mo agi ka sa dan. For example, na road. And then smooth gani na. So meaning continuous. No? And then moabot ka sa part nga arang karaf. Ana na po. That means ang road nga simentado ma-break na sa time nga naguba ang karsada. Okay? So mao na makaingon ta nga discontinuous ni nga part. So ang continuous kadto jong way bugto. Okay? So asa nga point siya mabugto dito siya mahitawag og discontinuous. Okay? So let's proceed to example number 2. Okay. Let us consider the graph of the function g of x is equal to 3x squared minus 4x plus 1 over x minus 1. So notice that ug atong i-trace ang atong graph from the left of x equals 1 to the right of x equals 1. Kani nga part man ni x equals 1, diba? So from left to right, may hollow here. So meaning, tig-trace na to diha, atong i-up atong pen, then usa pa ta mo continue. Right? So meaning, na ay hole ang graph. So since na may bangag here, that means the graph is discontinuous at x equals 1. So dili siya continue. Kayo imo pong analyson ang imong g of x here bisan pag dili ka mo tan-aw sa imong graph. Notice that at x equals 1, the denominator of your g of x will become 0 when we replace our x with 1. So 1 minus 1 is 0. So that means x equals 1 is not a domain of g of x. Okay? Let's proceed. Okay, what about the graph of the function h of x equals 1 over x? Is the function continuous at x equals 0? So notice that if kung atong drawing ta diri no, padong ta sa 0, then drawing na pud ta diri, padong na pud ka diri. So you are lifting your pen gikan diri mo imong mabugto siya ka mo drawing na pud ka diri. Okay? So na din nga part sa at x equals 0 nahimong nabugto ng imong pag-drawing. So the function is discontinuous at x equals 0. Okay, because when we replace our x with 0 here, the function h of x is undefined. So meaning x equals 0 is not a domain of h of x. So it is discontinuous at x equals 0. Okay? Okay, example number 4. Consider again the graph of h of x 1 over x. Is the function continuous at x equals 2? So, asa man ang x equals 2? So, tiadin he. Kaninga part. So we are going to trace from the right and from the left of x equals 2. So from the left, anak ka diri pa dong to the right. So you are graphing or drawing the graph without lifting your pen. So therefore, what can you say about this one? Is it continuous or discontinuous at x equals 2? Okay, so since smooth mga di man mo i-left ang imong pen when drawing the graph. So therefore, we can say that at x equals 2, the graph is, or the function is continuous. Whereas at x equals 0, the function is discontinuous. So, gato pong i-substitute ang atong x with 2. So, meaning, ang h of x, or h of 2 is equal to 1/2. So, define mo no. So, therefore, it is continuous. Okay. What are three continuous of continuity? A function is said to be continuous at x equals c if the following three conditions are satisfied. So meaning, pwede rin na mo o di ni mo i-drawing ang imong graph as long as these three conditions will be satisfied. So we can say that the function is continuous. So the first one is f of x or f of c exists. Then second one is the limit of f of x as x approaches c exists. And f of c is equal to the limit of f of x as x approaches c. If at least one of these conditions is not met, f is said to be discontinuous at x equals c. So, unsa ganito itong bahaton to test whether f of c exists. Ato ang buhaton, substitute the x in the given function with c. After that, you are going to find the limit of f of x as x approaches c from the left and from the right. So if the limit of f of x as x approaches c from the right is equal to the limit of f of x as x approaches c from the left are equal, so we can conclude that limit of f of x as x approaches c exists. Then after that, you are going to compare f of c and the limit of f of x as x approaches c. If they are equal, so f of c is equal to the limit of f of x as x approaches c. So if these three conditions are met, so we can say that the limit of the function exists. Okay, so let us try. Kanang dili na nato i-drawing at nang i-test ng three conditions. Example. Determine if f of x equals x squared plus x minus 2 is continuous or not at x equals 1. Okay. Sige. Okay, ato i-test using the first condition. So, f of 1 equals, substituting x here with 1, so we have 1 cubed plus 1 squared minus 2. So f of 1 is equal to 1 plus 1 minus 2 equals 2 minus 2 equals 0. Okay. What about the second condition? We are going to find the limit of f of x as x approaches 1. From the right, okay, 1 from the right, so atong i-replace ang atong f of x, ang mga x f of x with 2, then 1.9 to 1.9, 1.8, 1.7, isa pa, 1.1, 1.001. So notice that ang iyang value will be closer, or ang value sa f of x will be closer and closer to 0. So that's why 0 at ang answer. And the limit of f of x as x approaches 1 from the left, left na po sa 1, sa man, 0.009 or 0.999, then 0.05, padungan to sa 0 at x equals 0. So, gikan sa x equals 0, then, moadto ka sa 0.02, ngadto sa 0.5, ngadto sa 0.999, ato pa mo closer and closer ka sa x equals 1, ang imong value is 0 also. Imong value sa f of x will be getting closer and closer to 0. So from here, we can say that the limit of f of x as x approaches 1 is equal to 0. Okay. So, and the third one is, since ang imong f of 1 is equal to the limit of f of x as x approaches 1, so therefore we can say that f of c is equal to the limit of f of x as x approaches c. So since the three conditions are met, so meaning f of x is continuous at x equals 1. Okay? Okay. What about example number 6? We have to determine if f of x equals x squared minus x minus 2 all over x minus 2 is continuous or not at x equals 0. Okay, checking the three conditions. For the first one, f of 0 is equal to, we have 0 squared minus 0 minus 2 all over 0 minus 2. So we have negative 2 over negative 2 is equal to 1. Okay. For the second one, we are going to find the limit of f of x as x approaches 0. from the right and from the left. So notice that from the right we have, as x approaches 0, the answer is 1. And from the left, the answer is 1 gihapon. So therefore, the limit of f of x as x approaches 0 exists, and the answer is 1. So since our f of 0, which is 1, is equal to the limit of f of x as x approaches 0 is also 1. So therefore, the third condition is met, that f of 0 is equal to the limit of f of x as x approaches 0. So we can conclude that f is continuous at x equals 0. Okay, example number 7. We are to determine whether f of x equals x squared minus x minus 2 all over x minus 2 is continuous or not at x equals 2. So in this case, solving for I, notice that when x is 2, f of 2 is equal to 2 squared minus 2 minus 2 all over 2 minus 2. The numerator is 0 and the denominator is also 0. So since the denominator is 0, that means this function is undefined at x equals 2, right? So since does not exist man atong f of 2, okay, undefined man atong denominator, so that means the first condition is not met. No, napalpak na daan ang first condition. So there's no need for us to find or to check whether the second and the third conditions are met. So therefore, from here, we can conclude that f is discontinuous at x equals 2. Okay, ana rano. Okay, what about number 8? Determine if f of x equals x plus 1 if x is less than 4, and then quantity x minus 4 squared plus 3 if x is greater than or equal to 4. We are going to check if this function is continuous or not at x equals 4. Okay. Checking for the first condition. What is f of 4? So since this is a piecewise function, we are given two conditions that if x is less than 4, this function will be used. So since we're to test for f of 4, so the second condition will be used. So to do that, we have to substitute the x in here by 4. So that's why we have 4 minus 4 squared plus 3. So it should be 0 plus 3. So f of 4 is equal to 3. That is the value of the function at x equals 3. What about the second one? So we are going to find the limit of f of x as x approaches 4 from the right and from the left. Okay, from the left. So that means the values of x gets closer and closer to 4 from the left. So from the left man, we are going to use x is less than 4. So unsa may value when x is from the left of 4. So the value of the function of f of x gets closer and closer to 4 plus 1. That would be equal to 5. So gets closer and closer to 5. What about the limit of f of x as x approaches 4 from the right? So we are going to use this one, the second one, which is x is greater than 4. So ito i-test gikan sa 5 approaching to 4 from the right. So the value is 0 plus 3. That would be equal to 3. So since limit of f of x as x approaches 4 from the left is not equal to the limit of f of x as x approaches 4 from the right, this means that the limit of f of x as x approaches 4 does not exist. So since does not exist, meaning the second condition is not met or failed, or na failed man ta din sa second condition. Therefore, we can say that f is discontinuous at x equals 4. Okay. So I think that's all for 3.1. So I do hope you learned something today about the topic. So let us have more for 3.2 and for topics 4.1, 4.2, and 4.3. So thank you for listening. God bless everyone.